Okay, welcome. This lecture is about logistic regression. Logistic regression, it is an extension of multiple regression, okay, in which the y variable has only two values. It is either 0 or 1. Y only have two values, either 0 or 1. X could be any value. And you have maybe x1, x2, x3, etc. Okay, and usually this y equal to 0 or 1 refer to the membership. For example, are you an international student or not international student? Okay, so are you a union member or you are not a union member? So that is the logistic regression. The mathematics behind logistic regression using the logarithm function or exponential function. Okay. So this is a logistic regression model. Y either is 0 or 1, just two values. The average y, EY represents the average y equal to exp, means exponential function. Okay, so if exp, for example, raised to power 5 means e raised to power 5. Okay, and if you use what is e? E is the natural number. And in Excel, you can just type in e equal to exp. So 5. So this number you got 148. Just for example, what is ex looks like? exp5, 148. Okay, so on the numerator, you have e raised to power beta 0, beta 1. Those are the coefficients. And you have independent variable x1, x2, x3 until xk. And on the denominator, exactly the same as numerator, except you use 1 plus. Okay. So we also use pi represent the proportion of category A occurs. Okay. Remember y only have 0 or 1. If the result of y is 1, we want to know what is the proportion, what is the probability of having y equal to 1. We use pi represent the population proportion. All right, so if you have, because of this reason, the regression equation, we just simply said pi equal to this one. Okay, and do a little bit algebraic manipulation. This equation is the equivalent of this equation. They are the same equation, different expression. Okay, so to simplify this equation, we just use pi star represent this logarithm function, and we transform the logistic model into looks like the normal multiple regression. Okay. So this is the mathematics behind logistic equation. Use logarithm function, use exponential function. The dependent variable y only has two values, either 0 or 1. And in logistic function, we use a term odds. This odds is the same as if you study statistics, the same concept. For example, if there is 40% chance of rain, then there is 60% chance of not rain. So the definition of odds equal to 40% divided by 60%, 0.667. Okay. Another example would be if there is 80% chance of rain, the odds is 80% chance rain divided by 20% not rain. You have 4. Okay. So the assumption behind the assumption for logistic regression is sample size, make sure it is not too small. Okay. And make sure your sample do not, if you have many x, x1, x2, x3, those x are not related to each other. So multicollinearity. Okay. And make sure you do not have outliers. Those are the assumptions for logistic regression. Okay, next, I will use an example. This example is about a sleep problem. I already uploaded this file into D2L. Unfortunately, you cannot use Excel to do logistic regression. You will only depend on SPSS, or if you know R, you can use R. Okay, we are going to use R in our last lectures when we're going to study the second textbook. Okay. So for now, we use SPSS. The data file is sleep. Okay. There are many variables in this data file, but here we only interested in 4 variables. The first variable is Y. Do you have a sleep-related problem? The answer is either yes or no. Okay, so we use 0 represent no. We use 1 represent yes. That is my Y. Do you have a sleep-related problem? We ask people. They're telling us either 0, 1. Okay, and then we have several predictors. Predictors also called independent variable. We have people's gender. We have people's age. We also have the number of hours they sleep. Okay, and we also, those are our X. For example, this is my X1, X2, number of hours sleep, X3. We have, if people have trouble falling asleep, that is my X4, that variable. And then if they have difficulty staying asleep, that is my X5. So total I have actually 6 variables. One is dependent variable Y, other variables X1 to X5. Okay, so logistic regression allows us to assess how well my 5 variables, my 5 predictors will explain one dependent variable. Okay, so the research question could be framed as what factors predict the likelihood that respondents would report they had a problem with their sleep. Okay, so those are the background information. Now I'm going to open sleep 5ED data file and to conduct logistic regression. Okay. I can't open the sleep file because, sorry, Colin, the sleep file is a SPSS file. You cannot open it if your computer does not have SPSS. Is the Excel file available? I could translate, I could export this into SPSS file. You need to give me 1 second. Okay, so I'm going to open the sleep file. So sleep 5ED. Try to locate that file. I try to locate the data file. It is not here, so I'm going to go another location. I will go to Block University. I have sleep 5ED. I have this data file here. Okay. It is an SPSS file, but SPSS does not have functionality to conduct logistic regression, so it is useless to produce SPSS file. Sorry, okay. I could export this one into SPSS, but there are many variables. You get this SPSS file, so what? You cannot do the logistic regression using Excel. Okay. All right. So there are many variables here. See, there are 55 variables, but here we just focus on 6 important variables. 6 important variables. Okay. It is here. Try to locate those variables. So this is the procedure on how to do the logistic regression. All right, so you go to analyze regression, and then go to binary logistics. Binary logistics and dependent variable. So dependent variable is a problem. Do you have problem sleep? That variable name is a prob sleep. Okay. So try to locate that variable. Prob sleep P. This variable, okay? This is our Y. This is my Y. And for 5 independent variables in logistic regression, they call covariance. Okay, covariance. So I'm going to move 5, x1, x2, x5. The first one is sex, and then H. After that, it is a get sleep, REC. Get sleep. Get sleep, REC. Get sleep. Get sleep, REC. Okay. And then I have stay sleep, REC. Stay sleep. This one here, stay sleep, REC. So one more variable, hours, week, night, sleep, hour. Because there are too many variables, I have trouble locate the right one, hours. Hours. Hours, week, night. was week 9. Try to locate the last variable. It is this no, this is week hours. Hour week 9. Okay, let me double check if we have hour. Yeah, this is the one. Okay, so I put all those variables. After that, click the categorical, and then highlight the first variable. Make sure it is a contrast. First contrast. Highlight and click first. First, change contrast. So make sure this is the first. Okay, actually you can do all the variables here. Sleep. Stay asleep. Those are categorical variable. Do not do the hour sleep. Then click make sure it is first. Yes, each value is first. And then click continue. So under the options, we need classification plots. So basically what we are doing here, we want to depend on the 5 independent variables to put people into 2 groups. One you have trouble sleep, the other no trouble sleep. That is our purpose of this example. So we need also to select goodness of fit, case-wise listing of residues. We also need confidence interval estimate for the parameters. So where is that? CI. Yeah, this one here. Okay, confidence interval. So that's it. We click continue, and then we click OK button. Okay. So once you get this, let's look at some important variables here. So starting from here, logistic regression. Total, we have 271 respondents. Okay, and our dependent variable is either 0 or 1. Okay, 0 represents no problem in sleep, 1 represents has problem. Okay, and those are not important output. Then we have a classification table. This is important. Okay, this is important. So overall percentage, overall we can correctly classify 57.3 people into 2 categories. One is troubling as when you have difficulty sleeping. The other is no difficulty in sleeping. We can have 57% correct rate. Okay, and this one is the variables in the equation. Those are actually the parameters. So this is the constant, negative 0.293. And this number, if you use exponential expression, it is 0.746. Okay. And those are the variables not in the equation. It is not that important. But this one is the omnis test of model coefficients. it is a chi-square test. The p-value smaller than 0.01, so the model is significant. Okay, and over here, the model summary. Model summary, there are two statistics are important. One is Cox-Snell R-square. The other is Najd-Kurtke R-square. The meaning of those R-square is you need to translate this decimal into percentage. So for example, this is 39.9%, and this is 53.5%. It is like the R square. Remember, when you do multiple regression, what is the meaning of R square? R square represent how much change in Y can be explained by different X. Okay, so for this example, the changes in Y, so the model explains 40% to 54%. Changes in Y are due to the variation in different X. Okay, that is the meaning of those two statistics. Okay, and then you have this contingency table. And finally, this classification table is important. You need to know each and every number because there are questions in test 2. And also will be in final exam to analyze this table, So this table, if you studied statistics, it is like the observed value versus expected value, okay? So for the given data, maybe I will use I have the analysis here, not here. Okay, so I will just do the analysis here, output. Okay, let's analyze these 3 numbers. Oh, I cannot, so I'm going to copy to my OneNote so that I can make annotation. Okay, maybe I will put the result just here. So I want to analyze the classification table. So starting with these 3 numbers. So this number said, this is predicted. Okay, predicted no, predicted yes. Okay, so the model, the computer predict there are 112 people have no problem sleep. There are 26 people has a problem sleep. Okay, but as a matter of fact, the original, you have observed original data. In observed data, if you count how many people do not have problem sleep, if you count, the number is, so the observed people has no problem sleep is 112 plus 26. That is 138. Okay, so when you go back to the data, you count. You count, do you have you locate that variable, then it is 0 or 1, that number. Okay, so you get the idea, there is a 0, 1, do you have problem sleep or whatever, so you count, and the result is 138 people have no problem in sleep, but the model, the computer model predicted 112 has no problem sleep. So the percentage you did correct is, this is percent, 81.2% is 122 over total number of people who do not have sleep problem. That is how that number comes. You get 81%. Okay, and similarly, how do you get this 78%? So 78% you count. The computer predict how many people have problem sleep. There are 79. Okay. Total number of people is 24 plus 79. That's how you get this 76%. And the overall percentage, how do you get this number? You use number of people you predicted have problem sleep plus number of people don't have problem sleep, 79, divided by total number of people, 112 plus 26 plus 24 plus 79. And this result is 79%. Okay, so that is a classification table. Okay, classification table. And if you go to the output, the chart, so this chart is overwhelming when you look at this chart. Okay. So first of all, N represents, I will copy this chart so that I can make annotation. Okay, this one here. So small n represents you do not have problem sleep, no problem sleep. So Y represent you have problem sleep. Okay. Remember our dependent variable, either 0 or 1. This is a no problem sleep. This is has problem sleep. So the probability of having problem of sleep is 0.5. Just two outcomes. Okay, so the probability is 0.5. So the cutoff point is 0.5, the cut value. So this is the cut value. On the left, if our model is perfect, we should see all the N on the left. And if our model is perfect, we should see all the Y on the right. I mean, the cut value is 0.5. Okay, but we don't. That is because we are not 100% prediction. Remember, our overall prediction is 79%. That's why when computer predict, they put some Y in the null category, and they have some N in the yes category. Okay, so this is how you interpret the membership. This is this graph, classification graph. Okay. Any questions? Any questions? All right. So that concludes the logistic regression. Okay. Any questions? Okay. May I ask why it is 79? Oh, sorry, I just saw this message. Why 79 plus 112? Good question. Why you add 112 plus 79 you want to calculate the percentage of correct prediction. See, if the observed is null, the predicted is null, you make correct prediction. And if the observed is yes, prediction is yes, you make correct prediction. So those numbers represent correct prediction. Over how many total numbers? All these numbers are total number. Out of this total number, you make 112 plus 79 number of correct prediction. That is how you add those two numbers. How we hope that answer your question. Okay, thank you, Dominion, to answer that question, to find the average overall percentage. Test 2 have this question. I just changed the number. Make sure you understand the calculation I did here. Okay. Okay, sum up, great. Any other questions? Okay. Do we have the completed form in test 2? Oh, the format of test 2, let me stop recording then, because this is another topic.